Okay, so how's stats going? I hope all is going okay. And if not, if you have any concerns or any questions, you can certainly ask me. This is video 5, and I will just say a couple of things before we start. I hope that you folks read the announcements. It's very important to read the announcements. I try to answer questions in announcements. Also, I go to chat room, and there are times when I may miss some aspects in chat room. But anyway, I try to check it at least once or twice a day, both chat rooms, and at times I'll be leaving announcements. Well, today what we're going to be talking about is the types of distributions or the different types of curves that we have in statistics. Now, to start with, we are looking at what I call a mesocurtic curve. That's the same thing as a normal curve, and I just want to have a chance to visit with you about the percentage of it. This here is a normal curve, not taking into consideration the artwork. Kind of looks like an abnormal curve. But anyway, it is a normal curve with the percentages in each standard deviation. Now, these percentages do not vary. The standard deviation can vary. The standard deviation can be whatever your figures give your standard deviation value. So this here will always stay in a normal curve, 34%, 34%, and you'll notice that we have 68% here, and I believe it's around close to 90% here. When we get out here, we get out at 95%. Right in the center of a normal curve is the mean, median, and mode. Now, this is important to remember because this doesn't always happen with some of the curves that we're going to be talking about. A name to keep in mind is mesocurtic curve. Now, meso, I equate that to the middle. So this is a normal curve, the mean, median, and mode right in the center, and it is a mesocurtic curve. Now, if we would have IQ scores on a curve, we have the mean, median, and mode at 100. This has a standard deviation of 15. Like I say, not all distributions will have the same standard deviation. But this for IQ scores has a standard deviation of 15, meaning that right in the center with our mean, mode, and median, we have 100. And then for each standard deviation, the value of each standard deviation in this particular curve is 15. So from here to here, 115, because we add 15 onto the 100, and then we add another 15, and we have 130, and another 15, and we have 145. This is the positive side of the curve. Now, if we go on the negative side of the curve, we have 85, because we take 15 from 100, and then we have 70, we take 15 from 85, and then we have 55. Now remember, this is the normal curve or the mesocurtic curve. Then we have some skewness, and our curve leans. You might say that that's what skewness stands for, or skew is a leaning. The high point, where most of the numbers occur, is the mode. The next point is the median. The next point is the mean. Now, if we have given a test, and there's a lot of low scores in that test, we would have the bulk of the low scores down in here, and then you will see the tail here. The tail is positive. So remember that. The tail is positive. This is skewness. And you go with the tail. When it skews the other way, again we have the mode being at the high point, the number that occurs the most, and then we have the median, the middlemost number, and then we have the mean, which would be the average of the number. Now, the tail goes towards the negative side, so it is negatively skewed. Then for our next curve, we have kurtosis. Now, the two words that we want to remember here is kurtosis and skewness. Now, this is kurtosis. Now, this here is a peaked curve, which means that your standard deviation will be closer together. Now, it is called lepto. Now, remember that our curve, our normal curve, is meso, or meaning in the middle. This here is leptokurtic. And it refers to, kurtosis refers to how peaked these are. So this would be rather peaked here. The data would be, and the standard deviation would be squeezed together on this, and lepto means to leap. So if you can associate leap and lepto with a higher curve. Then we have a platykurtic curve, which is relatively flat on top. Here. And platykurtic, to me, I associate with the name flat. So this here is flat, which means that our standard deviation will be spread out more on this platykurtic curve, and we will not have the high mean. So we have mesokurtic, which would be your normal curve, which would go in the middle here, leptokurtic, which means to leap, and we have platykurtic curve. So these are the curves that you should remember. And again, I will review these with you. We have kurtosis and skewness. And kurtosis, then, we have three curves. We have meso, which is in the middle. We have lepto, which is higher, and you leap, and lepto. And we have platykurtic curve, which is relatively flat. And then we have kurtosis, and kurtosis means to lean a certain way. And if we have the high scores in the upper end, we would have a negative skewness. The skewness goes with the tail. And if we would have the scores, most scores in the bottom part, and the tail going towards the right or to the positive end, we would have a skewness to the right or to the positive. Remember that in the middle of the high point of a skewed curve, the high point is the mode, and then next we have the median, and then next we have the average or the mean. So these are really our 5 types of curves. Keep these in mind. Write them down. The best way to remember is to write this material down so you can remember where and what they mean. Because you may look at a curve in your research, or when you're reading research, you might see it skewed one way or the other. Now, what is interesting with these is that we can work. Most of the work that we do will be equated to the mesokurtic or to the normal curve. But we also can work with the skewed curve. And we will have the definitions and the operations for the skewed curve. So please remember each of these as you go through this, and we will see you on video 6. Hope all is going okay. If you have any questions or any concerns, again, please ask.